There we go. Okay, so I think I updated your worksheets. All these are showing F prime graphs, derivative graphs shown. So first thing I like to do is to begin to indicate what we're working with. This is not the original graph. This is not the location of points on the graph. These are actually slope values of a graph. So this is actually showing slope of 3 or slope of some positive value. And on the original graph, it's going to look a lot different than what we see here. So to help us remember what we're looking at, I like to indicate the actual slope value that's occurring whenever the graph is in these locations. So whenever it's below the x-axis, the actual graph is going to be decreasing. So even though it looks like it's increasing here, these are all negative slopes. So on the actual graph, the graph is going to be decreasing with various values of negative slope, but these all amount to negative slope. Some steeper than others, but they're all negative slope. Anything above is going to represent positive slope, and anything on the x-axis is going to be slope 0. So these are the points that we're going to focus at the beginning, because these are going to be our critical points that go on our slope sign line. And just so that I can make this a little bit easier to graph, let's say that the graph went through -4. So let me redraw this graph here. Okay, let's say it went through -4. So then we place all of our critical points, all of our x-intercepts on our f prime sign line. And I like to, if there are endpoints provided, I like to include those endpoints as well. So my x-intercepts are at -4, -1, and 3.
Sorry, is there a reason why 3 and 9, I mean -5 and 9 are on there? Just because they're like the endpoints of the graph.
Yes, those are there for endpoint reasons, because let's say later on I ask you what is the interval that the graph is increasing or decreasing. You would put parentheses -4 to -5 to -4, ... 3 to 9. So they kind of give yeah. So I guess we could make an argument that the graph extends to infinity, but let's say I gave you indications where the endpoints were, then we would have to include those endpoints as part of our interval. But I guess number 1 is kind of vague, right? I didn't really specify the interval, so I guess you could say negative to positive infinity without issues. But I just want us to practice, if there were intervals, that we include them in our sign line.
Okay, cool. Thank you.
Okay, so we look at -5 to -4. I know the graph is decreasing here, but these are all various values of positive slope. And so even though the f prime graph looks like this, the actual graph is going to show positive slope. So we know that all this region is going to represent positive slope here. And then between -4 and -1, these are all values below the x-axis. They all are going to represent negative slope. Between -1 and 3, positive slope. These are all negative y values. So negative y values on the f prime graph will translate to a negative slope on the original graph. So this is really helpful because our actual graph is going to resemble the path of these arrows. The graph is going to be rising until a relative max at -4, decreasing to a relative min at -1, increasing to a relative max at 3, okay, and decreases after that. Okay. Now the F double prime sign line, we can also grab information about concavity of the original graph based off the F prime. So what we don't want to do is we don't want to look at F prime and say, okay, look, this looks like concave up, this is concave down, this is concave up. Yes, for the shape of this graph it would be, but we're talking about concavity of the original graph. So we have to interpret things, we have to look at things a little differently here. So first up is identifying the POIs. So recognizing that your point of inflection, your POIs of the original graph is going to be the relative max and mins of your F prime graph. Okay, and that's where we start as we build our second derivative sign line. So we pick off the peaks and valleys. -3, 1, 7. Okay, so they go onto my second derivative sign line. Okay. And here we see we can actually get information about concave up, concave down by looking at the slope of the F prime graph. So whenever my F prime graph is showing a negative slope, that's indicating that the original graph is going to exhibit concave up behavior. Sorry, concave down behavior. So negative slope of F prime translates to concave down on the original graph. Positive slope on the F prime graph is going to translate to concave up. And then between 1 and 7, negative slope is going to translate to concave down. And then 7 to 9, positive slope, concave up. Okay, any questions so far?
No, I think I kind of got it.
Joe, are you good?
Yeah, so far I feel good about it.
Okay. All right. So I think this is the most important part. If we can get to this part, then everything else is going to be a little easier because now things are more straightforward. Whatever we see is what we're trying to replicate in our graph. Okay? We want our arrows to match on our graph. We want the concavity to match. So now it becomes more straightforward. The cryptic part is trying to get from here to here, right? Because this is not the shape of the graph. This is not what you see as increase, decrease, max, min, concave up, concave down. We have to know how to interpret it. So that's the hard part there. Yeah. All right, so now we can move on to our f of x graph. Our f of x graph is going to show the same, the slope behavior of the original graph. And I talked about how there's a relative max, relative min, relative max. Right now, the y values is not important. If we can just create a graph with the shape that is shown here, the location is not going to be, is not something that we know how to do yet. So we expect a relative max at -4. So I'm just going to give myself a target for relative max. When I think of relative max, I think of a value that is maybe a little higher than everything else. So I'm going to just give my target, give my point a relatively high point. -1, I'm thinking, okay, I want a value that is a relative min. So I'm going to target a point that is a little bit lower. And then 3, a relative max. I'm going to target a point a little higher. So Okay, but your graph may be a different location, which is fine. Ultimately, we just want our graph to match the rise and fall behavior of our arrows. Okay. So I'm going to do a draft because I don't want to fill in my concavity just yet. I just want to do one thing at a time. Okay. So I'm just going to trace my graph here. I know I want a relative max. I want my relative min. I want my relative max again. And I don't really care about concavity or point of inflection, not yet. Okay. I just want to have something to work with. Okay. So now let's work in the curvature of the graph. So I'm going to start with my point of inflection. So these are going to be the transition points from one concavity to the next. And again, these values, we know that these values are going to fall in line with the path of the graph. So I'm just going to look to see, okay, I made my rough sketch. Where does -3 fall on my rough sketch? So -3 looks like it's falling somewhere around here, and I'm just going to mark wherever I had it on the graph. 1 is somewhere here. And then 7, oh, I need to go a little further. Seven is down here. Right, but my graph keeps decreasing, right? So I kind of have a general idea how the graph is going to look, right? I have my general path. So now all I'm doing is I'm just going back. I'm not creating a new path, okay? I'm just going back and trying to clean up my path. Okay, so think of concavity as you're cleaning up the path, but you're not going to deviate from the path much, okay? So between -5 and -3, I should have started here, right? From -5 to -3, I want my graph to be concave down. So from my starting point to my first target POI, I'm going to make sure that it's a nice concave down shape. And then from -3 to 1, I want to make sure that it's a nice concave up shape. 1 to 7, I want this all to be concave down. And then from 7 to 9, concave up. But notice that we want to maintain this decreasing, right? So when we make this concave up, we're not going to make this go back up, right? We're just going to show a portion of the concave up. Okay, any questions there?
For the last part, so when you didn't show it go all the way up, if your interval was, if it was like instead of 9, if it was like maybe 15 was your endpoint, would you show more of the concave up?
You mean like actually going up?
Yeah, if like let's say like the endpoint was
Right.
a little farther down
Yeah.
the X part.
Well, it depends what the rest of this graph shows, right? Let's say on the F prime graph, that graph actually dips above the x-axis. Then we're going to have some positive slope behavior, and then we would have rising. But we have to make sure that our initial, if this is what we're dealing with, then we want the behavior of the slope to be true.
Okay.
So I guess, I mean, this graph, if it did extend to 15, maybe it would have gone up. Yeah, I think it would, right? It would go up, and then eventually it would have positive slope, and that positive slope would indicate yes. Then this graph will show kind of a more complete concave up shape. Yeah.
Okay, thank you.
Mm-hmm. Okay, F double prime. Now we're moving on to the second derivative graph, but the second derivative graph, we're just going to base it purely on this. Okay, we're not looking at anything else. This is the only thing that we're building our second derivative graph on. Okay, so our second derivative graph has a y-axis that's defined a little differently. The y-axis is not the location of the original. It's not the slope of the original. It's going to be the concavity of the original. So to help me remember what I'm looking at, I'm going to indicate concave up, concave down, and then my point of inflection, critical point, is going to land on the x-axis. Okay, so I first start off with my critical points, my x-intercepts. I didn't give myself enough room here. So negative 3, 1, and 7. And I just want my graph to be located above or below, depending on what symbol I see. So if I see concave down, I want this portion of my graph to live below the x-axis, but it's going to connect to these points. So these points kind of help give me some anchor points that know it kind of helps guide me a little bit. So from -5 to -3, I want my graph to be in the negative region, but it has to go up to that point. So it has to be something like this. Between -3 and 1, we want the location to be above the x-axis. So it's going to have to be, but we have to come back down, right? It has to come back down to our critical point. And then from 1 to 7, below the x-axis. And then between 7 and 9, above again. All right, any questions with 1? All right, let's try number 2. Same thing. F prime graph is given. Okay, so I'm going to mark off what I'm dealing with here. Focus in on my x-intercepts. These are my starting points on my slope sine line. I think I said -8 to 6 as my interval. Or my endpoints. All right, -7, -2, 5. Okay, we look at the location below the x-axis. That's decreasing. Above the x-axis, it's increasing. Here, still above the x-axis. So maps to positive slope. And then finally, from 5 to 6, it's below the x-axis. So location-wise, it's below the x-axis. That's going to translate to a negative slope on the original. Okay, second derivative sine line, we know that we want to target our point of inflection, and those are going to be the max and mins of the f prime graph. So our points of inflection doesn't quite land at a nice, let's say that's at -5.5. This is -2, and then 3. Or 6. Okay. Now we look at the slope, right? So positive slope is going to translate to concave up. Let me highlight that here. Okay, positive slope is concave up. Negative slope is going to mean the graph is going to show concave down. So we see that we have positive slope from -8 to -5.5, and again from -2 to 3. So that's going to translate to concave up. Okay. Negative slope, it's going to translate to concave down. All right, so now we have everything that we need. There's no need to look at this graph anymore. Now we're building everything off of our notations, our symbols, our critical points. Okay, everything that we need is here. So we expect a relative minimum at -7 because the graph is falling, followed by rising. Neither at -2, there's no change in signs. And we expect a max at 5. So I'm going to create a first draft just based off of this. And then I can work in my concavity, my curvature, point of inflection after I have my first sketch. So I want to just, we don't want these to go on the x-axis, right? We want to create a situation that will actually mimic the path of this, the arrows here. So I want a relative min at -7. So I'm going to target a point that is relatively low. -2. My graph is going to be somewhere in between, right? It's going to rise and levels off, rises again. So -2. Maybe I can target a point that's somewhere in the middle. And then at 5, I'm expecting a relative max. So it's a little bit higher. Morning. So here's my path here. Relative min. Rises, levels off, continues to rise. Relative max. And then decreases after that. Okay, next step, we go to our concavity sine line, second derivative sine line, and we plot wherever the graph lands at -5.5. We know that's going to be a target for us for our point of inflection. -2, 3. Okay, so now I'm just going to be updating my graph, not going to create a new path. We're just kind of cleaning up our path a little bit. Okay, so from -8 to -5.5. Concave up. So I'm going to show concave up in my first interval here. Then we know that there's a switch here to concave down. Kind of over exaggerating so we can see a little better. -2 to 3, concave up. And then from 3 to 6, concave down. F double prime. Again, we're just building it off of this. This is the only thing we're going to look at as we build our second derivative graph. Let's label what above and below the x-axis represent. Concave up is above, concave down is below, point of inflection on the x-axis, so that's where we start. Okay. These are nice points to start because we know our graph will go through those points. It's kind of act as anchor points for us. So first thing is concave up. We want the graph to be above the x-axis, but it has to come back down to this point, right? So something like this. Below the x-axis, so it's going to have to go down, but loop back up. -2 to 3 above the x-axis, concave up. And then finally below. Okay, any questions there? Okay, so 3 and 4 are more of the same. I think I'll probably have a chance to go over it this afternoon for students who want to attend the afternoon help session, but you guys have the key. So I think if you guys know how to do 1 and 2, 3 and 4, just more of the same, just extra practice for you. Okay, you guys feel good?
Yeah, definitely.
Better.
Feel a lot better.
Good. Yeah, so you guys have the key, right? So, practice number 3 and 4 on your own, and that will kind of help solidify whether you're good with this section or not.
Thank you.
Yeah. See you in class. See you, Joey.
Right.
Bye.
Thank you.
Sloan.
Have a nice day.
Yeah.